This is Ivan Donchevsky, the author of Procedural Environment Generator plugin for Unreal Engine. In today's video, I want to show you how you can generate the whole districts filled with buildings with this plugin. The idea is that it's not that obvious how to set everything up to generate building or even different kinds of buildings together. So I wanted to get some easily accessible assets. So in this case, I decided that I want to take free assets from Unreal Marketplace, and I will give you the link to those which I used in the description for this video. I haven't used anything extra for this tutorial, only the assets which could be found in this modular building set folder here. That's just the set I added from Epic Launcher. So here I have the map with WFC building actor, which is an actor built from WFC actor class provided by the plugin. I have set it up everything because it might take a while for you to combine all static meshes together to create all the actors for actual generation. They are placed here, and one of the cool things that you can actually combine several static meshes in one actor and then use them during the generation. So I have two kinds of buildings here. First one is made of these red bricks, and the second one is made of light bricks and the store on the ground floor. So let's first look at some of the actors I used inside as the blocks for generation. Most of the time they consist of not too many things. So for example, here are only two static meshes with windows, some divider between floors, and the cube, which is not visible. I used it to adjust the sizes. So if I make it visible, it will show you the size of one block in the building. So this helped me to adjust the heights and their placements, but usually it's disabled because you don't want to put these cubes in the real level. What about ground floor? So one of the examples with storefronts is here. So let's open it and look at it. So this is the front itself. The part with pedestrian line and the part with the road here, because right now everything is connected to roads. You can see this is already one of the examples of generations. There is a road around everything. And one thing to mention, it's not the ideal level. You can generate it much better. So this is just a setup to show you the concept, the example of how it's possible to do with the simplest combinations of components. So there are also ones for roof, for the road itself, for the roof borders. You can see them here. And there are some tricky assets like corners. I added them a bit later. These are inner corners, and they allow you to make your buildings not always rectangular, but also provide a bit more interesting shapes. I don't have them here in this attempt of generation, but we'll eventually see some of those. But the most interesting part is indeed the rules part. How to set everything up inside your main actor. So as usually I have this big list of components here, but what you see here are not actually the components. These are the mapped actors, which should be set up separately. So this is a good opportunity that you can mention all these as components for this actor inside here. So they're not required to be real actors in your editor. They are only children of your WFC actor. But you can set here the combinations, which component is represented by which actor. So you can select here from the list the one that you want to be placed, and you will see this actor here directly in the blueprint preview. Currently, and this is something I noticed during recording of this tutorial, I have the same names for the component and for the actor. So in one of my next updates, I want to add another check mark that you want to automatically map the same names with the same, the same component names with same actors. So you won't need to create this big list. So right now I have almost every component mentioned here, and it will shrink this list to like only several elements. But let's go to the rules. So there are plenty of fronts here, 8 of them. They have different static meshes here, so they look differently. So I decided I want to take all of them and use all of them. And what's interesting about them, that their connectors are set up the way you can connect them only by different sides. So here is 10 and it's flipped. That means that this one can be connected. Let's focus on the one which I'm talking about. So this 10F flipped can be connected to 10 straight only. So in my first attempt, this one was also 10. I will change it to show you how that looked. So if it's also 10, that means that this actor can be connected to itself, but only with right side connected to the left side. Not that it has pedestrian line on the different sides of the main front. So this gradation makes it impossible to set them in opposite directions. But right now I have 2 different connectors here, and the purpose of that is that I wanted to make buildings longer than 2 elements in width. So I have another set of the same 8 components here, which have the opposite connectors here. So first one had 10 here and 20 here. This is the same regarding flipped and straight, but with different the opposite connector set. What that means is that they will always come by pairs. So you can't place the corner, for example, next to 20 because corners only have connector number 10. Exactly about how you set up the corners. This is probably one of the most interesting parts. So let's see. Which corner is this? Let's check. Oh no, that's not the one. That's the corner for the roads. But there is also the corner for the ground floor. Storefront corner it's called. That's the inner corner. And there is also an outer corner for them. Where is that? Yeah, that's called floor corner for some reason. That doesn't matter, but this is just a piece of pedestrian line. It has both connectors 10 and 10, but this one is for Y, not for X. And you can see in the shadows how this can be connected to the sides of the building. So it is set up that only fronts with 10s can connect to the corner. So if these fronts had 20 on the left side, they could not connect to the corner because there is no corner with 20 connectors. So that means that there will be no buildings with only one side and then corners from the both sides of it. So at least two of them will be placed. There are also other ground floor blocks placed here. They are a bit lower in this list because I've added them after I had everything set up for the first building. So they are called ground floor red. Let's focus on them. Here they are. The idea is very similar for them. In this case, I decided not to add two copies of the same asset. So this is a bit worse because that can actually mean that they have oh no, they can actually have also another copy. Yeah, I remember now. So there are also two other ground floor sets for the red bricks buildings, but the idea is that only ones which have the wall without window can connect to the corner. So this one with two windows can only go inside the building. So it has 21 on the both sides, flips and straight again as before. So that works the same way. But the corner for it, which is called floor corner red, can only connect to 11 here and here again. And 11 is always a connector for the wall here, yeah. So you will never end up that two windows are on the corner. This is probably not too realistic, but I decided to use that kind of rule to show again how this could be set up, that you can set up specific connections near the corner. So this red 1 and red 2 are exactly symmetric, and it has 11 on the left side and 21 at the right side. which means they could connect either to each other or to the ground floor with two windows. You can see that in the generated example. So all these, all these corners are with the empty wall connected to them. So that's the ground floor which we just saw. This is the same one. So what else have I not shown? The road. Road is quite complicated because you need to think of different ways you need to connect it. So let's probably look at the fixed components. I have, as I mentioned, rows on all four sides of the map. So -1s mean that it's the last location in this coordinate. So if I resize the map to say 20 by 20, this will mean 19. So if I resize it to 30 by 30, it will mean 29. And you can see that the road is on all sides of the map. The solid ground is meant to state that the level always starts from the ground and it's always placed on the 0 coordinate by z. Yeah, this is quite obvious why this is required. And I also set it up that the topmost layer should be empty, so it's filled with air, so we will not have any buildings which don't have a roof and just go infinitely in the sky. Yeah, and with these restrictions, everything else is set it up. So let's look at these restrictions here. Empty is very simple. It has connector number 2 in all horizontal directions and 100 100 for Z, so it can connect to itself in all directions, so empty can really connect to another empty tile anywhere. Then there is the solid ground I showed you. By the way, they don't have any meshes or any actors assigned to them. So for solid ground, this is zeros in horizontal direction and 900 up, 9000 down. This is done so that it can never be placed anywhere in the map because there are no 9000 connectors anywhere else. But 900 could also be found in several solid. So it's the simple solid which is placed inside the building. It has 900 as a minus connector and everything else as zeros. And there is also another solid here which has all zeros. And this is the most common one. So we first place the one with 900 on the bottom and then everything else is filled with this solid. This is something we don't see because it's the filling of the building. It helps the generation to put the internals of the building and then put the other sides of the walls on the map. So this is the easy part. By the way, you could see that the weight of this solid is quite low, so it's below 1. This means that we don't want to have too many fat buildings. We want them to be as slim as possible because there are not really many buildings which are very wide. And this helps quite a bit to achieve that part. So, by the way, I have currently shown you only ground floors, but they are the most important because the biggest part of the generation is driven by the ground floors. This happens because we start from the ground, and the most restricted parts in the map are next to the ground, so they are placed first. So by the way we pick the ground floor, everything else could be placed on top of it. So we of course need to have also first floors set it up properly, like here, but they are mostly affected by the vertical connector, so they should be able to connect to the ground floor on top. So it has connector number 1 here, which is the same as connector number 1 here. And to achieve easier the higher floors ability, so you can have not 2 floors but 10 floors, for example. The first floor has the same Z connectors for up and down, so they can connect to itself many times. And the roof border, which we have here, has the same connector in the bottom. So the roof border is connected to one of the first floor or second floor or whatever tile, and has air on top of it. So you remember that empty component had air connection equal to 100. So what else do we have here? I mentioned the road. Yes, the road is complicated. It's the most simple asset here, so it's just the black road. But it has to have different connectors, unfortunately, because we don't want the road to fill the whole map, so we want to force it to connect to the buildings. So currently it's allowed to have only a single width of this road. You can create more complicated rules to have it wider, for example, to have some avenues which have these roads stacked, but it may become a bit harder to set them up, but I'm sure it's possible. Right here, the ordinary road connector is 3. 3 means another road in all cases, so only roads have connector number 3. But 1 flipped means that it can connect to 1 straight. And where can we find 1 straight? Is the storefront. It has y plus equal to, so it's this one looking at us. So this piece, the small piece of road, can connect to the road. And we force that, so every storefront has this connector. So that means that we connect all buildings to the road from this side and from this side as well. But we have corners, and they make road rules a bit more complicated. So let's focus again here. We need to have, for example, road corners, and their connectors are much more complicated because you need to trick them and connect as if it's a building front, just in some cases. That's why they have 1 straight in this right direction. This is almost the same road, so it has 1 flipped and 1 flipped here as the previous one, but this is 1 straight, which means it can also connect to another road which expects the building at this point. And I believe I also have another road corner example. Not the example, but the components set it up here because I needed something else or not. Let's look. Yes, I see it. So that's road corner 3. It's even more complicated because it doesn't have any 3's at all. So it has one flipped on all sides. And this is required because I introduced inner corners, and inner corners are probably the biggest pain during this generation because you need to set them up really carefully. So from the first glance it looks weird. So it has one flipped on all sides, which feels like you could set storefronts on all sides of them, so making the holes in the buildings or something even more weird. But we have some restrictions for the corners so they cannot go together and you don't get really thin holes on your map. So I can briefly show you the roof, because roof is not so complicated, and then go to inner corners as the main complication of this generation in general. So the roof is pretty simple. It has all the same connectors in all directions equal to 60. It has air on top of it, and it has solid in Z minus direction. This is obvious, so it should have empty space on top, and inside the build it should have inner part of the building inside it. Then there is a roof border which should connect to this roof, so it has 60 there. It should connect to itself on the both sides, and it should have one of the first or second or whatever floors on the bottom, and again air on top. So the connector for border is 50. This is also flipped and straight thingy because you cannot connect it in the opposite direction, only side by side. So you can expect that the regular corner also has 50-50. Let's just check it. Yeah. 50-50 are here. And 2 means it can connect to air, which is outside of it. So we have this for all corners. They should connect to air. And there is a special connector in my case for all corners, which are a bit different from everything else. So in this case is 200. We can go to the first floor corner. It has 200 here, and the floor corner should have the 200 on top. Yeah, here it is. And 900 as the connection to the solid underground is here. So we have went through corners. So let's go to the complicated part, inner corner. So it comes first here as the first floor, which, as I said, determines everything else. I again set it up as a separate vertical connector for them, so it's 250 in this case, and it will also affect the floors on top of it. The interesting part here is that it should connect to solids there and to other parts of the floor as the corner, but in different directions. So here in X plus and Y plus, it should connect to either sides or the regular corners. So itself, it looks simple, but I mentioned that you need to cover this kind of situation where you have two sides on the both sides, and you still need some road to mesh this corner. That's the road tile I showed you before with one flipped on all directions. So the same inner corner exists for all floors. So it's actually next to this one. So it has 250 here, different connectors again for both sides. And of course the roof part exists as well, so it's a special roof inner corner here. Let's move to it. Yeah, my recording makes it a bit laggy as usually, but everything should work much smoother when you just work with your plugin on your own. Okay. So what happened here, 60 connects to the roof, to the flat roof part, 50 connects to the roof borders. They can be found here and here. And we have 250 on the bottom, which is a special connector for the inner corner. So I think I've worked through most of them. There are some special cases, as you saw. So the part with the bricks look very similar, but they have a bit different connectors because you need to connect this specific tile to the corresponding part of this kind of building. So you cannot mix first floors from one building and second floors from another one. And this is done intentionally so you can have different buildings placed on the map, but the final way they will look depends on the first tile you place for this kind of building. So if you place a first floor for the first building, the whole building will be of this kind. If you place the first floor for another building, the whole building will be of this kind. Yes. And I guess there are only parts I didn't cover about restrictions which I had to place here. Oh yeah, this is, yeah, I also had to set special solids for the second kind of building. So I invented a new connector number 700, and I did it so that the parts inside buildings have the same walls as outside. So you can see here it's also red. If I didn't have special solid inside this building, it would be possible so that these walls are white. And this is not usually what happens in real world, so I decided I want to have special solid to cover this case as well. Yeah, and by restrictions I meant mostly the these voxel restrictions you can find here. Let's go back to the preview. So I will click through them through some of them and show the important parts. So here I put it roof border for all storefronts and all other ground floor tiles because you don't want to place the roof exactly on the ground floor. And by connectors, it looks possible. It could be solved in different ways, so you could set different connectors here and for the first floor, but then you need several tiles for first floor, and in this case it was easier to just set the restriction, don't place roof anywhere here. So they all have this kind of restriction. It's the same for them. What else do we have? Let's look further. I'm pretty sure I had some corner restrictions. Let's try to find them. Yeah, that's one of the most noticeable parts. So this is inner corner, and we really wanted it not to connect to, because it has solid connectors on these two sides. We really wanted it not to connect to anything except solid. So in this case, I solved this by putting everything else here except solid here. There could be also different ways to solve it. You can find out something more elegant, but since I have not too many elements here, and I also don't have too many corners, I've just manually set it up, all these exclusions here for the corner. And another important part is that it was enough to set it up for only ground floor, because if you don't put anything else on the ground floor, that means you cannot also put them on the next floor, so you don't need to set it for every tile in this case. Yeah, there is one exception for regular corner, which can be found here. It cannot connect to itself. This is important, so you don't have the islands without buildings inside the road. But if you want to have islands, you can remove this restriction. This is fine. Islands are probably also fine in some cases. Same one could be found for this one. It also shouldn't connect to itself. Yeah, again, you don't need for the first floor. By the way, I forgot to show you first floor corners, because they look very interesting. You see that they don't have any mesh at all, because you don't need anything here. You just need to set that this is a special case when the walls connect. So this component is needed to set the rules and to show that it's different from regular air. Yeah. And let us see. I think there are not too many restrictions left, so I have mostly covered everything. Actually, by the order of these elements, you can see in which order I have added them. So which ones I had first, set it up. I did some progress. First I had only ground floor, set it. Then I added first floor. Then I added different corners. Then I added the second building. So I already had map working with the first building. I continued adding them, and let's look how the generation works. So let's probably check the log output. Okay, yeah, this is pretty good example. There are several inner corners here. You can see this one, for example, or this one, and this makes the map look much more interesting than in simpler cases. Yeah, there are actually some wider rows because we added some special road tiles here, so this configuration became possible, and I guess this looks pretty cool. So we have two white buildings placed here, and everything else is red in this case. Let's try again probably. Again, it's a bit laggy because of my recording and not the fastest computer possible. Yeah, this time everything is red. By the way, the fact that we have quite a lot of red while having so many storefronts here is that storefronts have the weight of 1, and these ground floors of the red brick, they have higher weights, which means we will not always pick the storefronts presented in bigger amounts, but we'll also be able to pick those. Probably I can even decrease the weights here because I feel I have a bit too many of them. So it's very important to adjust the weights if you think you have too many elements of this type. But you need to kind of understand how the generation is processed. So you need to check out which tiles are actually placed first. So you need to understand your rules pretty well in order to have to adjust your map accordingly. And I think I will create a project and put it somewhere, so I will probably update the description for this video and put there a link to the set it up map like that. So yeah, I will create a separate project for it. So you will be able to click through everything here and see how it's set it up, because I'm not sure it's quite easy to understand just by looking at the video, so you probably want to touch it, but I try to uncover the details to show you the important pieces of this generation. Yeah, I really hope it helps you to generate your maps, to generate your buildings, and you can improve it further and get much better architecture than I have. You can, for example, add more kinds of buildings, like you have 10 different ones. Oh, this is funny. I like it. You can make different floors look differently, so you can have different kinds of actors for different floors. What you can also do is you can change the heights of different floors. There is a new setting. There are plenty of them. First one is voxel height, which makes it possible to set the height of your floor different from the width. So I extensively used it here. So the tiles are much wider than they are in the Z direction. And another one is this voxel heights array, which is empty by default. But you can set the individual heights of different floors. So in my case, I have underground and ground floors with the height of 400. So storefront is a bit higher than everything on top of it. So this is 350 taken from the voxel height setting, and the exceptions are underground and here on the first floor, on the ground floor, sorry. So I believe these settings will help you significantly with buildings generation. So go ahead, experiment, and share your results. And thank you for watching this video. Thank you very much. Have a good day.